All right, so this is just another practice problem to give you a chance to kind of see another one that I've done. This is number 4 in the practice D section on page 55 of the textbook, if you want to open your textbook and take a look at this. So it says a driver of a car traveling at 15 meters per second applies the brakes, causing a uniform acceleration of -2 meters per second squared. How long does it take the car to accelerate to a final speed of 10 meters per second? And then how far has the car moved during the braking period? So all physics problems are more fun with a picture. This picture of the car, and we have its initial speed of 15 meters per second. So let's make our table of what our knowns are. What are the things we know? Well, we know the initial velocity, so we know VI is 15 meters per second. And we know acceleration is -2. So think about what that means. If the car has a positive velocity and a negative acceleration, then that means its velocity is going to decrease. Essentially what's happening is this acceleration means it's gaining negative velocity. So if the velocity and acceleration have opposite signs, something important to note, that if the acceleration and the velocity have opposite signs, then the velocity will decrease. So that's only if they have opposite signs. Okay, so let's continue with our problem. So we know the acceleration is -2. It says, how long does it take the car to accelerate to a final speed of 10 meters per second? So we have our let's do that in black. So we have our VF is 10 meters per second. What are we trying to find in part A of this problem? So what's the thing we're trying to find? We're trying to find how long does it take the car to accelerate? So that's going to be time. So we're trying to find time. So we now look and we think about our equations, and we have initial velocity, acceleration, final velocity, and time. So the equation that applies, and again, you should be making an equation sheet. You can just make it on PDF Expert, or you can do it on a piece of paper. But any equation you get in a video, and I'll let you know if it should be written on the equation sheet, put it down. And you can use that on a test, on any test. So the equation we want to use is going to be, for this one, we want to use the acceleration equation. So acceleration is equal to the change, so VF minus VI divided by T, or the change in T, right? So VF minus VI over T. So this is the equation for acceleration. It's the change in velocity over time. So acceleration we have, so I'm going to plug these numbers in. Okay, we see I keep track of the, it's important it's VF minus VI, because now this side is going to be 10 minus 15, which is going to give us a negative number, and this side is also negative, so that tells us that our time will be positive. So you'll always know if you get a weird answer, like say we got an answer where time came out negative, we would know that our signs were somehow incorrect. So now I'm going to multiply both sides by T, and that cancels the T out here. I'm going to bring the T to this side. So now I need to divide one more time. I'm going to divide both sides by -2. So I'm going to divide -2 to this side. So now we have T. T is equal to 10 minus 15 over -2, which comes out to to 2.5 seconds. So Add now t to our list of knowns. It is now 2.5 seconds to go to the 10 meter per second speed, velocity. So now second part says how far has the car moved during the braking period. So now we're trying to find, instead of t, we're trying to find delta x. So again, the equation we could use here, right, would be our new equation. So the equation we're going to look at. I don't know why I made that a G there. That's not a G. Equation we're going to look at is delta x is equal to 1/2 VI plus VF times T. Okay? So we can plug everything in here to solve for delta x. So we're going to plug VI, VF, and T in. And what I get here, this is going to be delta x is equal to 1/2. And then VI is 15. Oops, sorry, I have those backwards. It doesn't matter since we're adding them. It doesn't matter which order you write them, but just to be consistent, VI, VI is 15, VF is 10, and the time is 2.5 seconds. Okay, I forgot my units here, meters per second. Okay, and then that's a plus sign there. Okay, so now we have 1/2, 15 meters per second plus 10 meters per second times 2.5. And we solve that, and that gives us a distance or displacement of 32 meters for the car. Okay, so there's another problem. You can follow that and try some on your own.